Hello everyone. Today we are going to discuss one of the topic from numerical methods. Today's topic is numerical integration. We are going to study as many as 3 methods for numerical integration. First of all, we will see what do you mean by numerical integration and which are the important points belonging to numerical integration. So let us see one of different important points one by one. First of all, we know that definite integration, that is y dx or fx dx within the limits a to b always represents area under the curve y equal to fx x-axis and the region bounded between two straight lines x equal to a and x equal to b. Now this area under the curve we can find out numerically, and that is called as numerical integration. So let us take h as the differencing interval. We know that h means difference between two consecutive values of x. Now we have to define one more letter, that is n. N is nothing but number of intervals, and remember the formula, n is equal to b minus a upon h. B is the upper limit of the integration, a is lower limit of the integration, and h means difference between two consecutive values of x. Now if number of intervals are n, then total number of readings of y are equal to n plus 1. For example, if n is equal to 4, then number of readings are 5. How number of readings are 5? For example, y0, y1, y2, y4, these are the total number of readings. Now if n is equal to 7, total number of readings of y are 8, that is starting from y0 to y7. Now here this area under the curve that can be calculated numerically using 3 rules. And which are the 3 rules? Let us see one by one. Number 1 rule is called as trapezoidal rule. Number 2 rule is called as Simpson's 1/3 rule, and third rule is called as Simpson's 3/8 rule. So these are the 3 rules that we are going to study today. Now here trapezoidal rule, first of all, we are going to take. Now we have to remember different conditions before application of these 3 rules. And what is the condition for this? Trapezoidal rule can be applied anytime, means whatever may be the value of n. If n is even, if n is odd, that can be applied easily. Now this rule is comparatively less accurate. So as far as your exam is concerned, unless and until it is asked to calculate using trapezoidal rule, you are not going to decide that you are going to choose trapezoidal rule. So this is comparatively less accurate. Now what is the formula for that? That is, see this formula, integration of y dx is equal to h by 2 in bracket y0 plus yn. What do you mean by yn? Last reading of y, and plus 2 times all readings in between initial and final reading. So this is the simple formula that you can remember, that is h by 2 in bracket y0 plus yn plus 2 into bracket y1 plus y2 plus dash dash plus yn minus 1. y0, y1, y2, these are nothing but the values of y at x equal to x0, x1, x2, etc. Now let us see the next one, that is Simpson's 1/3 rule. Now what is the condition for Simpson's 1/3 rule? That we have to see. Now this rule is applicable when n is even. Means, for example, if n is 3, if n is 5, we cannot apply this rule. This is applicable when n is 4, n is 6, n is 8, or n is 10. Now next is, this rule is quite accurate rule, and here if you want to choose the rule in examination in particular, then Simpson's 1/3 rule can be chosen over the trapezoidal rule. Okay, now let us see what is the formula for this. Here rule name is 1/3 rule. Here outside the bracket h by 3 is present, and first part is same as that of trapezoidal rule. y0 plus yn means initial reading plus final reading. Then we are having two brackets in between. First 4 times all odd readings, that is y1, y3, y5, etc. plus 2 times all even readings, that is y2, y4, y6, etc. So this is the formula for Simpson's 1/3 rule. Now y0, y1, y2 are nothing but values of y at x equal to x0, x1, x2, etc. Now let us go for third rule, that is Simpson's 3/8 rule. Now here we can see that in Simpson's 1/3 rule there was h by 3. Now in case of Simpson's 3/8 rule, you will find out 3/8 outside the bracket along with h. Now again this rule is quite accurate rule, and when this can be applicable, as we discussed earlier, trapezoidal rule can be applied anytime. Simpson's 1/3 rule is applicable only when n is even, and now we can see that this rule is applicable when n is multiple of 3, means it can be 3, 6, 9, 12, 15, etc. Now this is one of the accurate rule and must be preferred over trapezoidal rule. Okay, now here we can see that Simpson's 1/3 rule and Simpson 3/8 rule, how this can be compared. If for example, if n is equal to 6, n equal to 6 means n is even as well as it is multiple of 3. But in this case you can choose 3/8 rule because this is even more accurate rule, and that's why this concept of n must be understood perfectly. Now let us see this formula. Integration y dx from a to b is given by 3h by 8. That exactly I was talking. Initially we have already seen Simpson's 1/3 rule, there was h by 3 there, and in 3/8 rule there is 3h by 8. See that formula, that is y0 plus yn. Once again addition of initial and final reading plus 2 times. Now we can see these readings are multiples of 3, y3, y6, y9, if it is there y12, etc. and then plus 3 times remaining readings. See that here y3 is not present, y6 is not present because y3 and y6 are included in the first bracket. Again same, y0, y1, y2 are nothing but values of y when x is equal to x0, x1, x2, etc. So this is the concept of these 3 rules that we have discussed earlier. Let us see now examples based on this. Okay, so we will discuss different examples to understand this concept. Let us take example number 1. See the example, that is use trapezoidal rule to numerically evaluate I is equal to integration from 0 to 1 x into e raised to x square dx by taking h is equal to 0.1. In this example, generally value of h is always given, and also compare the approximate value with the exact value. What do you mean by exact value? That exact value can be calculated using the direct integration. See that this integration x into e raised to x square can be calculated directly. Now let us see the solution one by one. Your first job is to write down y is equal to given expression, that is y is equal to x into e raised to x square, and then we can see that from 0 to 1 h is 0.1, that is given. What it means h is equal to 0.1? We have to find out the values of y when x equal to 0, then 0.1, then 0.2, then 0.3, etc. And in this manner you will get different values of y. So let us calculate these values. You have to do calculation of your own, and you have to check that whether your values are matching with this standard values or not. So here these are the different values of y we are getting. When x equal to 0, we are going to call y as y0. When x equal to 0.1, we are going to call y as y1, and so on. Now we can see that here total values of y are 10. In short, what are the total number of readings? As we see, readings are starting from y0, end is y10, means total number of readings are 11. And if total number of readings are 11, here we cannot apply Simpson's 1/3 rule as well as Simpson's 3/8 rule, and that's why question is given only and only for using trapezoidal rule this can be calculated. In other words, if in examination it is not mentioned for this example that use trapezoidal rule, even though you have to apply same rule, because we cannot apply remaining two rules because of the condition, because of the limitation of that n. Now we can see that here, as per trapezoidal rule, first of all you have to write down the formula with reading 10, that is h/2 y0 plus y10 and plus 2 times all the readings, and after that here we are going to substitute all values of y whatever we have calculated. Let us do the substitution one by one. Also we have to put the value of h as 0.1 and then put all the values, and then we have to use calculator to find out this final answer. Now you will see that the final answer comes to be 0.865098. Always write down number of decimals for accuracy. Do not write down only 2 or 3 decimals, otherwise accuracy gets damaged. Okay, now let us see exact value. Exact value, as I told you earlier, we can calculate using integration. So we have to find out this integration directly. Integration 0 to 1 x into e raised to x square dx. Okay, now you must know the basic knowledge of integration. This is a integration by substitution, because whenever it is e raised to x square, we can do the integration only and only when we do the substitution x square equal to t. So if x square equal to t, then 2x dx is equal to dt, and since we want to replace x dx, that is nothing but dt by 2. Whenever we do the substitution, we always have to see the limits, but for this particular example, limits remain same even after the substitution. At x equal to 0, t equal to 0, at x equal to 1, t also equal to 1. So values of limits are same, and then e raised to x square becomes e raised to t, and x dx will get replaced by dt by 2. 1 by 2 we can take outside, and then we know that integration of e raised to t is e raised to t. Let us put upper limit and lower limit 1 by 1. So here we get e raised to 1, that is e, minus e raised to 0, that is 1. And now by putting the value of e, you know the value of e, approximate value is 2.71. So this is the value 0.8591409. Now we can see this value, exact value, with the value which is calculated using trapezoidal rule, and you will see that value which is calculated by trapezoidal rule and value which is, we can say, exact value, they are almost same. Okay, so this is the concept of the trapezoidal rule that we have seen using this example number 1. Let us take now example number 2. So example number 2 is evaluate integration from 1 to 2 dx upon x square by dividing the interval into equally spaced intervals of width 0.25. Compare the result with exact value. Here also we can observe integration dx upon x square can be found out directly using integration, and that itself is called as exact value. Let us see now solution one by one. Let y is equal to 1 upon x square, and now by substituting the values from 1 to 2 with the difference of 0.25, we have to tabulate the result. Here first of all we will see that n is equal to b minus a upon h. Value of a is 1, value of b is 2, and h is given as 0.25. In short, 1 upon 0.25 means 4. So value of n is equal to 4, means value of n is even. So when n is even, we can apply Simpson's 1/3 rule. Remember, we can apply trapezoidal rule anytime, but we are going to give preference for Simpson's 1/3 rule because of accuracy. Now let us see the values one by 1. So when x is equal to 1, we get y0 as 1. Now put x is equal to 1.25 to get corresponding value, that is y1, 0.64. When x is equal to 1.5, we get y2 as 0.444 recurring. Then next value is x is equal to 1.75, we get y3 as 0.32653. And when x is equal to 2, we get y4 as 0.25. And now here, as we discussed earlier, since the value of n is even, we are going to apply Simpson's 1/3 rule. We are going to write down the formula first, that is I is equal to integration from a to b y dx h by 3. Now remember, since the value of n is equal to 4, here y0 plus y4, and then 4 times y1 plus y3 plus 2 times y2. So this formula is to be used. Put all these table values in this formula to find out the value of I, and which is approximately equal to 0.5. Exact value 0.500416. Now we'll see that what is the value which can be calculated using the direct integration. So here exact value is given by 1 upon x square. We know that standard formula integration of 1 upon x square is minus 1 upon x within the limits 1 to 2. Let us put upper limit and lower limit. So minus 1 by 2 upper limit, lower limit minus sign, and this minus sign becomes plus, and then lower limit 1 by 1, that is 1. And then we can see that final answer is 1 by 2, and that is nothing but 0.5. So observe that value which is calculated by integration is almost same as that of value calculated using Simpson's 1/3 rule. Okay, so this is the comparison. You have to write down the statement at the end of example that values obtained directly and using Simpson's 1/3 rule are almost same. Now we are going to discuss example number 3, so that you will have all concept clear regarding this all numerical integration formulas. Now we will see now example number 3. Evaluate integration dx upon 1 plus x with 7 ordinates by using Simpson's 3 by 8 rule, and hence calculate log 2. Now here, instead of finding out exact value using integration, the question is slightly different. That is, in this particular example, we have to find out approximate value of log 2. One more difference is there if you compare with earlier 2 examples. Here 7 ordinates are given. You must be knowing ordinate means y readings. Values of y are called as ordinates and values of x are called as abscissa. So here 7 ordinates are there. Now here, whenever y readings are 7, it means that value of n must be equal to 6. As we discussed earlier, when n is equal to, when n are the number of readings, then or when n is number of intervals, number of readings are n plus 1. So similarly, we can say that when ordinates are 7, that is values of y are 7, and therefore n must be equal to 6. Now here we are going to use the formula n is equal to b minus a upon h to find out h. Here h is not given. In earlier example h was given and here n is given. So h is nothing but 0.5, that is upper limit is 3, lower limit is 0, n is equal to 6. Now we have to find out values of y with the difference of 0.5, 1 by 1. Now same concept as earlier, we can take y is equal to 1 upon 1 plus x, and by substituting the values of x right from 0 to 0.5, we can calculate all values of y. So let us see values of y again in the table. So when x is equal to 0, we get y0 as 1. When x is equal to 0.5, y1 is 0.6667. We have rounded off up to after 4 decimals. when x is equal to 1, y2 is 0.5. Then when x is equal to 1.5, y3 is 0.4. When x is equal to 2, 2.5 and 3, you can calculate all values of y one by one. And now we have to see which rule can be applied. So we have to apply Simpson's 3/8 rule, because n is equal to 6. n equal to 6 means these are the multiples of 3, and that's why here we can write down the formula 3h by 8, y0 plus y6, and then 2 times y3 plus 3 times y1, y2, y4, y5. Okay, and now substitute all these values in this formula, and then let us see what is the result that we are getting for this particular numerical integration. So here we can see that we are getting final answer as 1.388. Now after finding out value using this Simpson's 3/8 rule, the second part is to find out approximate value of log 2. Now how to find out that? We can see this. Exact value can be calculated using integration, that we know. So here integration 0 to 3 1 upon 1 plus x dx, we can write down the formula. You know the formula, that is integration of 1 upon 1 plus x is log of 1 plus x. Put the limits 1 by 1, upper limit and lower limit. In upper limit log of 1 plus 3, that is log 4. Lower limit log of 1 plus 0, that is log 1. And now log of 4 can be written as 2 log 2 using laws of logarithm, and log 1 is 0 and can be neglected straight away. Now we have to equate the value which is calculated by integration and which is calculated by Simpson's 3/8 rule in this manner. And after equating them, 2 log 2 is equal to 1.388. We can find out the value of log 2. So this is a different type of question. Second, as far as second part is concerned, that we have to find out the value of log 2 using this numerical integration. So this is the example number 3. Now we will proceed for example number 4. So example number 4, let us see what it is. It is quite different now, using Simpson's 1/3 rule. Now it is mentioned that we have to apply Simpson's 1/3 rule to find out integration 0 to pi by 2 sine of x dx by dividing interval into 4 parts only. What is the meaning of interval in 4 parts? Value of n is given as 4, means value of n is even, and that's why it is to be calculated using Simpson's 1/3 rule. Now let us see new concept over here, how to find out the values. First of all, we will see that n is equal to 4 and we have to calculate h for this. N is equal to b minus a upon h. Then h can be calculated as, that is pi by 2 minus 0 upon 4, that is pi by 8. Now whenever we are going to calculate the value of y at h is equal to pi by 8, either you are going to convert your calculator mode into radian mode, or there is alternate method as well. Here y equal to sin x upon x we have to calculate by substituting the values from 0 to pi by 2. Okay, so here difference is pi by 8. We will see that how to calculate this. Now next an important point, if you substitute value of x as 0 directly over here, then what happens? Y is equal to sin 0 upon 0. We know that sin 0 is 0, x is 0, and whenever it is 0 upon 0, it is called as indeterminate form, and therefore we are going to use the formula from indeterminate form, that is formula for limits, that is in limits as x tends to 0, sin x upon x is equal to 1. In other words, we can say that at x equal to 0, value of y is 1. Now important note here we have written, that is for sake of calculation, let us convert values of x in terms of degrees instead of radian. Our choice, as I told you, we can also write down values using the radian mode only, but for sake of convenience we will convert that into degrees. Okay, so pi by 8 means 22.5, pi by 4 means 45 degrees, 3 pi by 8 means 67.5, and pi by 2 is 90 degrees. So you have to take utmost care for solving such type of example. Now for denominator, important point, whenever we have converted values of x in degrees, that degree value can be written only inside the trigonometric term. When x is without trigonometric term like denominator, you have to put values of x in radians only. Okay, and now we will see, we can find out different values in this manner. Put x equal to 0, we get y0 as 1, and also we can see other values at pi by 8, at pi by 4, at 3 pi by 8, at pi by 2. Here in table we have written x as pi by 8, pi by 4, pi by 2, 3 pi by 8 like this, but in actual practice you can use pi by 4 means 45 degrees, 3 pi by 8 means 67.5 degrees, so on. And now write down the formula for this Simpson's 1/3 rule. After writing down the formula, you can put all these values whatever we obtain here, and after that you will get the answer using Simpson's rule as pi by 4 into this bracket, and the final answer comes to be 1.3707929. Okay, so this is all about the concept of numerical integration. We have solved as many as 4 examples for practice. So trapezoidal rule, Simpson's rule, 1/3 rule, and Simpson's 3/8 rule that we have studied today. Thank you very much.